The National Electrical Code, or NEC, provides specific guidelines for electrical installations in healthcare facilities, particularly in patient vicinity areas. Section 517.13 addresses wiring methods for these critical locations. Focusing on 517.13b, it outlines the requirements for wiring in patient care areas. An exception number 5, permits the use of flexible cords or cables where flexibility is essential. The NEC Handbook commentary elaborates on this exception, clarifying its intent and application. Examples of situations where flexibility is considered essential include pendant luminaires, candlesticks, and decorative light ropes. However, the use of flexible cords and cables is subject to additional conditions to ensure safety. Firstly, flexible cords and cables must be of type S, C, SGO, or SAINT. Secondly, they must not be smaller than number 18 American wire gauge. Thirdly, the cords and cables must be protected from physical damage through proper routing or mechanical protection. There are also limitations on length. Flexible cords must not exceed 3 feet in length, while flexible cables are limited to a maximum length of 6 feet. Technical field notes provide further guidance. Rigid metal conduit or intermediate metal conduit, also known as IMC, should be used in patient vicinity areas where there is a risk of physical damage to electrical conductors. This is particularly important in areas such as operating rooms or intensive care units. While flexible cords and cables are permitted where flexibility is essential, it is only when the conditions described in exception number 5 are met. Careful planning of installations is crucial to prevent damage to flexible cords and cables from rolling equipment, patient movement, or other potential hazards. The reason for the exception is that it recognizes that in some cases hard piping may not be practical or feasible, especially where flexibility is necessary for the proper operation of lighting equipment. Strict conditions are imposed to ensure that the use of flexible cords and cables does not create a safety hazard. In summary, the NEC permits the use of flexible cords and cables in specific patient vicinity applications where flexibility is essential, provided that the cords and cables meet specific requirements. These requirements involve type, size, protection from physical damage, and limitations on length. Areas with a high risk of physical damage to conductors require the use of rigid metal conduit or IMC. Remember that installations should be carefully planned to prevent damage to flexible cords and cables. When considering the use of flexible wiring methods in patient care areas, several factors must be carefully evaluated to ensure both functionality and safety. Firstly, the specific needs of the lighting fixtures should be considered. Determine whether flexibility is truly essential for their operation or positioning. Secondly, assess the potential for physical damage to the flexible cords or cables. Areas with heavy traffic, moving equipment, or potential for patient contact require more robust protection. Thirdly, ensure that the selected flexible cords or cables meet the NEC requirements for type, size, and length. Fourthly, carefully plan the routing of the flexible wiring to minimize exposure to physical damage and potential hazards. Fifthly, consider incorporating additional mechanical protection, such as sleeves or conduits, where necessary to enhance the durability of the installation. Sixthly, conduct thorough inspections of the completed installation to verify compliance with all applicable NEC requirements and ensure that the flexible wiring is properly supported and protected. Seventhly, implement a regular maintenance program to inspect the flexible wiring for signs of wear, damage, or deterioration, and promptly address any issues that are identified. By carefully considering these factors and adhering to the NEC requirements, healthcare facilities can safely and effectively utilize flexible wiring methods in patient care areas where flexibility is essential. It is important to stay updated on the latest revisions and interpretations of the NEC to ensure ongoing compliance and maintain a safe electrical environment for patients and staff. Now let's delve deeper into the specific requirements for flexible cords and cables in patient care areas, as outlined in the NEC Handbook. The commentary on 517.13b provides valuable insights into the intent and application of these rules. Regarding the types of flexible cords and cables permitted, Type S cords are heavy-duty service cords designed for use in damp locations and with portable appliances. Type SE cords are similar to Type S cords but have a thermoset elastomer insulation, making them more resistant to heat and oil. Type SGO cords are junior service cords suitable for light-duty applications in dry locations. Type SD cords are hard service cords designed for use in damp locations and with portable tools and equipment. The NEC specifies that the flexible cords and cables must not be smaller than number 18 American wire gauge to ensure adequate current carrying capacity and mechanical strength. Protecting the flexible cords and cables from physical damage is paramount. This can be achieved through proper routing, such as keeping the cords and cables out of pathways and away from moving equipment. Mechanical protection can include the use of sleeves, conduits, or other protective coverings to shield the cords and cables from impact, abrasion, or other potential hazards. The limitations on length for flexible cords, 3 feet, and flexible cables, 6 feet, are intended to minimize the risk of tripping hazards and reduce the potential for damage to the wiring. In areas where the risk of physical damage to electrical conductors is high, such as operating rooms and intensive care units, the NEC mandates the use of rigid metal conduit or intermediate metal conduit. These rigid wiring methods provide superior protection against impact, crushing, and other forms of physical damage. Careful planning of installations is essential to prevent damage to flexible cords and cables from rolling equipment, patient movement, or other potential hazards. This includes considering the layout of the room, the placement of equipment, and the anticipated movement patterns of patients and staff. By carefully assessing these factors, the risk of damage to the flexible wiring can be significantly reduced. The NEC exception allowing the use of flexible cords and cables where flexibility is essential recognizes that hard piping may not always be practical or feasible. In some cases, the need for flexibility may outweigh the additional protection offered by rigid wiring methods. However, strict conditions are imposed to ensure that the use of flexible cords and cables does not compromise safety. These conditions include the requirements for cord and cable type, size, protection from physical damage, and limitations on length. By adhering to these requirements, healthcare facilities can safely and effectively utilize flexible wiring methods in patient care areas where flexibility is essential. It is important to consult the NEC Handbook and other relevant resources to ensure a thorough understanding of the applicable requirements. Electrical inspectors and other qualified professionals can provide valuable guidance in interpreting and applying these rules. By working together, healthcare facilities, electrical contractors, and inspectors can ensure that electrical installations in patient care areas are safe, compliant, and effective. Continuous monitoring and maintenance of electrical systems are also essential to ensure ongoing safety and reliability. Regular inspections should be conducted to identify and address any potential hazards or deficiencies. Flexible cords and cables should be checked for signs of wear, damage, or deterioration, and replaced as needed. Electrical equipment should be properly grounded and maintained to prevent electrical shocks. By implementing a comprehensive electrical safety program, healthcare facilities can minimize the risk of electrical accidents and ensure a safe environment for patients, staff, and visitors. Now, let's consider some specific examples of how the NEC requirements for flexible cords and cables apply in patient care areas. In a patient room, a pendant luminaire suspended from the ceiling may require a flexible cord to allow for adjustment of the light's position. In this case, the flexible cord must be of the appropriate type, size, and length, and it must be protected from physical damage. The cord should be routed in a way that minimizes the risk of tripping or entanglement, and it should be inspected regularly for signs of wear or damage. In an operating room, where the risk of physical damage to electrical conductors is high, rigid metal conduit or intermediate metal conduit should be used for most wiring. However, a flexible cord may be necessary to connect a portable surgical device to a power outlet. In this case, the flexible cord must be of the appropriate type, size, and length, and it must be protected from physical damage. The cord should be routed in a way that minimizes the risk of interference with surgical procedures, and it should be inspected regularly for signs of wear or damage. In an intensive care unit, where patients are often connected to a variety of medical devices, flexible cords and cables may be necessary to provide power and data connections. In this case, the flexible cords and cables must be of the appropriate type, size, and length, and they must be protected from physical damage. The cords and cables should be routed in a way that minimizes the risk of entanglement or interference with patient care, and they should be inspected regularly for signs of wear or damage. In all of these examples, it is essential to carefully consider the specific needs of the application and the potential for physical damage to the flexible wiring. By adhering to the NEC requirements and implementing appropriate safety measures, healthcare facilities can safely and effectively utilize flexible wiring methods in patient care areas. Now let's focus on the types of tests performed on flexible cords and cables to ensure that they meet safety standards. These tests are important. For example, the voltage drop test measures the voltage drop along the length of the cord or cable when it is carrying its rated current. This test ensures that the cord or cable can deliver sufficient power to the connected device without excessive voltage loss. The insulation resistance test measures the resistance of the insulation material to electrical current. This test ensures that the insulation is effective in preventing electrical leakage and shocks. The dielectric strength test measures the ability of the insulation material to withstand high voltages without breaking down. This test ensures that the insulation can protect against electrical hazards under abnormal voltage conditions. The flammability test measures the resistance of the cord or cable to catching fire and spreading flames. This test ensures that the cord or cable will not contribute to a fire hazard in the event of an electrical fault. The physical stress test measures the ability of the cord or cable to withstand bending, twisting, and other physical stresses without damage. This test ensures that the cord or cable can withstand the rigors of normal use. These tests are performed by independent testing laboratories to verify that flexible cords and cables meet the applicable safety standards. The testing laboratories then issues a listing mark. A listing mark indicates that the cord or cable has been tested and found to comply with the safety standards. Healthcare facilities should only use flexible cords and cables that have been listed by a recognized testing laboratory. This ensures that the cords and cables have been subjected to rigorous testing and meet the applicable safety standards. In addition to using listed cords and cables, healthcare facilities should also implement a regular inspection program to identify and replace any cords or cables that are damaged or worn. Damaged cords and cables can pose a serious electrical hazard and should be removed from service immediately. By using listed cords and cables and implementing a regular inspection program, healthcare facilities can minimize the risk of electrical accidents and ensure a safe environment for patients, staff, and visitors. Now let's talk about the grounding conductor that the inspector had said. Section 250.118 in the NEC covers the types of equipment grounding conductors. Flexible metal conduit is permitted for grounding under certain conditions. Let's examine those conditions. Firstly, for trade sizes 3/8 through 1/2, the conduit is limited to a maximum of 6 feet and must be terminated in fittings listed for grounding. Secondly, for trade sizes 3/4 through 1/4, the conduit can be used for grounding without length restrictions if it is terminated in fittings listed for grounding. Therefore, given the installation consists of 1/2 inch flex, the length is limited to a maximum of 6 feet.